In this video we'll look at the angles of elevation and depression. Now elevation normally means up and depression normally means down. So the angle of elevation is measured from a horizontal line and then up to whatever it is you're looking at. So here we have our horizontal line and we are looking up to some object up here, and the angle of elevation is the angle from the horizontal upwards. Now the angle of depression, once again, is measured from a horizontal line, but then down to whatever the object is you're looking at. So here we are looking from the horizontal, we are then looking at some object down here, and therefore this angle here is the angle of depression. So both are measured from the horizontal, one upwards and one down. Now one feature of the angle of elevation and depression is that they are equal to each other from opposite points of view. So here we have the angle of depression, once again from the horizontal looking down, and then the angle of elevation from the horizontal here and then looking up. Those two angles are the same because they are alternate angles. If you recall, we have two parallel lines and a line that crosses those parallel lines. These two angles here are equal and alternate. And that's what we have in the situation here. So the angle of elevation, angle of depression are equal to each other. Now here we have an example. We have a ship out to sea and we have a cliff here of unknown height. We know the distance from the ship to the cliff is 3,700 meters, and the angle of elevation has been measured to the top of the cliff as 26 degrees. So we can use that to work out the value of h here, which is the height of the cliff. First thing we do is write down the trig ratio. So in this case, if I've got my angle of 26 degrees, I know this length here is the adjacent length, and height, the value we want to find, is opposite, and therefore the trig ratio is the tangent. So the tangent of 26 degrees is equal to, and its opposite on adjacent, so h on 3,700. To solve that, we make h the subject, and so that 3,700 is dividing on the right side, it'll multiply on the left side. And so h equals 3,700 multiplied by the tan of 26. So on your calculator, once again, make sure you are working in degrees, and we can put that into the calculator, and we get an answer of 1804.61. And that will be in meters. So there's the approximate height. Notice also that the cliff height doesn't include this little bit here because the angle of elevation was measured from a point above the water line. So if we knew that length, we'd add it on to work out the actual height of the cliff. Now, second example, once again we have our boat out to sea here. This time we don't know the distance away from the base of the cliff, but we do know the height is 1800 plus the height of the lighthouse is 70. And we have the angle of depression given to us here from the horizontal once again down to the line of sight, which is here. We have 30 degrees. Now, in order to work out D, I need to have an angle in this triangle. So this angle here is in fact the same as the angle of depression. So the elevation once again is the same as depression. So now I've got my angle of 30. This length is adjacent. This combined length here is opposite. Once again, I've got the tan ratio. So the tan of 30 degrees is going to equal, now the opposite length will be the 1800 plus the 70. That'll be 1870 meters. And the distance along the adjacent is d. Now in this case, I need to move d across the other side first, where it multiplies. So d tan 30 equals 1870. And now the tan 30 will divide to the right hand side, and we end up with this calculation here. So put that into the calculator, and we get an answer of 3,238.94. And once again, that's in metres. Right, so there are a few examples of how to work with angles of elevation and angles of depression.